In this section here, you can use the Identities formula sheet. So in this case, we're going to find exact values, and we're going to use a sum or a difference identity. So what you want to do is you want to look at how can I get 15 degrees either from subtracting two exact values that I know or adding two exact values that I know. So if I have the sine of 15, I'm going to do 15 I can get from a 60 and a 40 degree angle. So instead of writing sine of 15 degrees, I'm going to write as the sine of 60 degrees minus 45 degrees, because this is essentially 15 degrees. So I'm going to use the difference, excuse me, a difference identity. So this is the same thing as sine of A minus B, where A is 60 and B is 45. So I'm going to plug it into the formula. That is sine of 60, which is sine of A, times the cosine of B, which is 45, minus the cosine of A, which is 60, times the sine of B, which is 45. So then what I'm going to do is I'm going to substitute what's the sine of 60. So what's the y value at 60 degrees? That's root 3 over 2. Cosine of 45 is root 2 over 2, minus cosine of 60, which is 1/2, sine of 45, which is root 2 over 2. So when I simplify this, this ends up being root 6 over 4 minus root 2 over 4. So I have a common denominator, so I can just subtract these. So this is going to be root 6 minus root 2 over 4. Now you can't combine these root 6 minus root 2 as one term because there's two different terms. They're not like terms. So number 2, the cosine of 145 or 165. So how can I get 165 from two exact values? I can do that this is the cosine of 135 plus 30. So the cosine, this looks like the cosine of A plus B because I add them. So I'm going to go to the sum identity for cosine and plug in 135 and 30. So I have the cosine of A, which is 135 degrees, times the cosine of B, which is 30, minus the sine of 135 degrees and the sine of 30. So I need to evaluate the cosine of 135. That's going to be a 45 degree angle reference. So, and it's in the second quadrant where cosine's negative. So this is root 2 over 2. And the cosine of 30 is the x value at 30, so that's root 3 over 2. Minus the sine of 135, which is positive in the second quadrant. So that's root 2 over 2. And the sine of 30, which is 1/2. So now I just need to clean these up here. So this is going to be negative root 6 over 4 minus root 2 over 4. You can write it like this, or you can combine the numerators together. But this is the exact value. Third one, sine of 195. How do I get 195 degrees? So 180 and 15, nope, those aren't exact values. So I'm going to do 225 and 30. I think getting those two angles might be the hardest part for people. And I'm subtracting them. So this is a sine of A minus B. So I plug this in, and I get the sine of 225 cosine 30 minus cosine of 225 sine of 30. So sine of 225 is negative root 2 over 2 times root 3 over 2 minus the cosine of negative 225 is x is negative, so it's negative root 2 over 2 times 1/2. So just to simplify this, I have negative root 6 over 4 plus, because this is minus a minus, root 2 over 4. So when I combine these, I get negative root 6 plus 2 over 4. And then the last one, tangent of 75. So tangent of 75 I can get from adding 45 and 30. So I'm going to plug it in to my tangent formula for sum identity, which is, or tangent sum identity, which is the tangent of 45 plus the tangent of 30 over 1 minus the tangent of 30 times the tangent of 45. So the tangent of 45 is where sine and cosine are the same. So that's 1, because the ratio, when you divide two things that are the same, is going to be 1, plus the tangent of 30, which is root 3 over 3. So my denominator is going to be 1 minus root 3 over 3, because that's a tangent of 30 times 1. So I have 1 plus root 3 over 3 over 1 minus root 3 over 3. So I'm going to get a common denominator right here of 3 and 3 right here. So all I did was multiply 1 by 3 over 3. So now I'm going to have 3 plus root 3 over 3 divided by 3 minus root 3 over 3. Now, if I'm dividing these fractions, I can flip this one and multiply. So what's going to happen is these 3's are going to cancel out. So I'm going to have 3 plus root 3 over 3 minus root 3. So I'm going to rationalize this and multiply this by 3 minus root 3, or 3 plus root 3, the conjugate of the denominator. 3 plus root 3. So then this turns into, if I FOIL the numerator, it's going to be 9 plus 6 root 3, because that's going to be my outside inside terms, and then plus 3, because root 3 times root 3 is 3. So that is 12 plus 6 root 3. And my denominator is going to be 9 minus 3 root 3 plus 3 root 3 minus 3. So that's going to be 6. So in the end, I want to simplify. 12/6 is 2 plus root 3. So that's the exact value. I linked up a website that goes through the different cofunction identities. So these are proving, well, they look similar. This one looks almost like the cofunction identity. But first I just want to go over again that if you have the sine of a negative angle, so if you're starting right here and you're going to have, let's say, the sine of negative 60. So if I go down negative 60 degrees, look at the y value. This y value is just opposite of if I would have went up 60 degrees. So I'm just going to use 60 degrees as example right here. So in a 60, this is going to be root 3 over 2. This is going to be root 3 over 2. However, the sign of negative 60 is negative root 3 over 2. And the sign of positive root 60 is positive root 3 over 2. So you have one of the first negative angle identity, which is if you have the sign of negative theta, that's equal to the opposite of sine of theta. So if we did the sign of negative 60, we got negative root 3 2. If we do the sign of positive 60, we get the opposite of negative 3 root 2, which is positive 3 root 2. So these two back and forth. Same thing as if I was over in the second and third quadrant as well. The second negative angle identity is if you have the cosine of a negative angle. So let's do that same 60-degree angle. So if I have the cosine of negative 60, I'm not drawing my 60 very well, but the x value is going to be 1/2. But even if I did positive 60, the x value is still going to be 1/2. So cosine of a negative angle is still the same value. These are still both 1/2 right here. So I'm going to use that over here to verify this. So first I have to go back to my cofunction identity, which is the sine of pi over 2 minus theta is equal to the cosine of theta. And also the other cofunction identity, which is this cosine of pi over 2 minus theta equals the sine of theta. So this is so close right here, so I'm going to write it as the sine of the opposite of pi minus 2 minus theta. Because look, all I did was switch the two orders around. See how theta is going to be positive just right here, and pi over 2 is going to be negative. But now it looks similar to this part over here, where you have the sine of opposite theta is equal to negative sine theta. So this is actually equal to negative sine of pi over 2 minus theta. And we know that from our cofunction identity right here, this blue part, that this right here is actually equal to cosine of theta. So now the answer is negative cosine of theta. So on the second part, very similar. Notice how I wrote out, just like I put a negative in front of here and factored out a negative. I factored out a negative right here. So now I have cosine of the opposite of an angle measure. So remember, I'm going to look over here. Cosine opposite of an angle measure equals the cosine of the angle. It's the same thing. The x value is going to be the same whether it's positive or negative. So this is the same thing as cosine of theta minus 2. You don't need the opposite in there. Theta over 2 minus theta, or pi over 2 minus theta. And this is a cofunction identity because the cosine of pi over 2 minus theta equals the sine of theta. So we verified it. So you had to factor out a negative if the angle comes before this.